for a derivative given the chart over here, and how can we also scratch the graph. So when we're looking at this derivative equation, the first thing you want to consider is height 2 minus height 1 over time 2 minus t1. This equation is what you're going to use at least to solve the first one. So to solve the first one, you're just going to take the time 14, you're going to find where it corresponds on the graph, and then to determine what time 2 is, because we don't know the value of time 2, this is only time 1, you're just going to take the number closest to it. But this won't apply for every single question, so follow along. This will be 21 minus 14 over 54 minus 42. And if you're wondering where I got these numbers from, it was from their corresponding heights. And this should bring you this value over here, 1.71. And then when we're doing 21, we're not going to take from this set like we did last time. Instead, we're actually going to take from the numbers next to 21. So we're going to take from here, and we're just going to ignore this part. The reason why we're doing this is because this it's easier to estimate something that's like already in the middle. This was our beginning numbers over here, so we weren't able to take estimation from both sides of it, but in this case we can. So what we're going to do is we're going to write out in the same form as the equation. It will be something like 28 minus 14 and 63 minus 42. And this should get you 1.5, and these will be the solutions for the other ones. I do want to point your attention to 49. When doing 49, what you want to do is you just want to take the number that's like close to it. So I'm going to just do it on the calculator really quick. Yep. So instead of taking like the whole data set here, you'll just take this number and this number when doing 49. But for all the other numbers, if they have two numbers surrounding them, then you should just take from both sides. And then when we're sketching the graph, I kind of already have the solution down here. But the reason why it's the solution is because you're really just corresponding what you got in these values with the points that you'll find in the graph. So like in this example, you'll see at like 49, we calculated it to be 0.71, and here it's about 0.71. And then like you just look at the other points and verify. And then to know whether or not it's a negative or positive slope, you just look at whether the numbers are increasing as time increases or whether the numbers are decreasing as time increases. And in this case, the numbers are decreasing as time increases, therefore it's a negative slope.